Hello everybody and welcome to another Minecraft Science. Today we're going to be looking at a brief history of the Earth and the life on Earth. I don't know if that was implicit. Okay, anyway, life and Earth and stuff. Okay, that's what we're looking at today. Well, hello everybody. Welcome to a brief history of the Earth. We are starting at the very beginning. We're starting in the Precambrian. This is called the very start of the Earth was called the Hadean period, and it was theorized at the very beginning that this was the part of the Earth where no crust had formed. This was a nice big ball of lava magma type awesome rockitude. But as you can see, the Hadean period is this red bit. As you can see, MYA stands for millions of years ago. And if it's in the thousands, it's actually billions of years ago. For example, this one is 3.8 billion years ago. They found carbon, and it's not 100% sure whether this is, biological carbon or not. They think it is. So if it is biological carbon, that means that things like plants and stuff were starting to grow. So like 3.8 billion years ago, we start with carbon, which is cool. Carbon is cool. The Hadean ended. I'm not going to read all these out. I'm just going to go look at the numbers. But 3.6 billion years ago, and we started the Archean, or the Archean. I'm a geologist. I learnt from teachers. Hello, sheepy. My degree is in geology. I still don't know how to pronounce all this stuff. So, if you pronounce it a different way, cool. If I pronounce it wrong, fine. I don't care. So, we're still in the Precambrian. The Precambrian, I don't know if it's an era or an epoch or bleh. They found, at this point, 3.5 billion years ago, they think they found fossils. They're not 100% sure. But they found them in Western Australia. Slightly later on in the geological, they didn't find them in this period because humans haven't been around for that long. They did find fossilised bacteria. We're talking about, single-celled creatures, with a nucleus and not nucleus if it's bacteria. It's got genetic matter in it. They found fossilised bacteria that old. Okay? Just stating a fact. Okay. As we go on in time, we're still in the Precambrian. We go from the Archean to the Proterozoic. Now, the Proterozoic used to be the name for the Precambrian. They used to mean the same thing, but they don't anymore. And the Proterozoic is the last era. 100 million years ago. 100 million years ago. See how much time has passed since the beginning of the age, 2,500, to now. Sorry, that's 1,000 million years ago. I put the sign up wrong. Still, it's now 600 million years ago in that sign. And it's still quite a chunk of time. This is a long, long thing. Anyway, they theorised, hello kitty, goodbye kitty, that the supercontinent of Rodinia was around here. And basically all that means is that all of your continental crust and all the juiciness is in one big lump. And that's the flag I devised. I don't know what I was thinking when I was doing this. That's the flag. Okay, so that's 1,000 million years ago. God. 600 million years ago was the first multicellular organism. And they weren't very complicated. They were lots of, cells jammed together. Nucleuses in each of the cells. So they weren't very special. Until we get out of the Proterozoic and into the Paleozoic. Now, at this point here, 88% of all Earth time is gone. It's over with, it's done. Okay, 88% of the time that the Earth has been around, over. what we've got left, and this is why it's not to scale, is 12% of all of history, of the Earth. So this is the Paleozoic, and it's in the Cambrian, and that started about 540. This distinction isn't clear, which, as you can see from here, they're not 100% sure when each of these things started, so they've given us a rough estimate. Trilobites, yay! I love trilobites because they have awesome names. Trilobite means they're like woodlice, like with the hard exoskeleton and they're split into 3 parts. I like them because they've got cool names. These are my favourite fossils apart from like dinosaurs. The front part is called the cephalon, and sometimes in the middle of it, it's got this floaty thing called a glabella, which is awesome. And then you've got the thorax and the pygidium. Pygidium is like my favourite word in the history of words. So yeah, trilobites are awesome. They stick around for a long time, but they're a good zone fossil. Zone fossils are basically, how do I describe it? If you had a species that covered the entire world, had a short lifespan, died, and only existed in a good period of time, you could say, okay, that fossil is from 542 million years ago, but we know this because it only existed then. That's what trilobites are. There are so many different kinds of trilobites that they're a good zone fossil, like humans would be. We've covered the Earth, we have a relatively short lifespan, and when we die, we're going to leave lots of bones behind. So we're quite a good zone fossil. So yay. Weather, pretty freaking cold. And this lasts for the next one as well, the yellow one over there. The Cambrian is pretty dang cold. Lots and lots of many glaciers, as you can see from the snow. 505 million years ago, right. Trilobites are good because they have an exoskeleton which gets preserved. Things like, jellyfish, sponges, not so good at getting preserved. Now the Burgess Shale is awesome because it actually preserves a lot of like soft tissue, because it's made out of mud, and mud basically stops oxygen getting in when it gets laid down, and the Burgess Shale was laying down really, really quickly. So it actually preserved a lot of the soft tissue stuff, which is awesome for geologists, because now we know that there are lots and lots of soft jellyfish tissues. These are sponges, by the way, and I only included them, so I got to use the sponge for once. They are called archaeocyathids, which is a cool name as well. And then we ended the Precambrian. Not a lot's happened. We got trilobites, which are awesome. And moving to Ordovician. Ordovician, really cold as well. Around this time, we started getting these things, still with the trilobites, we started getting these things called graptolites, and graptolites are like little tiny 2 centimetre long things. But they have awesome names, and basically they're colonies of animals, living things, and they have these things, the green part, the leaves, is basically what houses them. So imagine if you're like in a building with other people, so like an apartment building, that's basically what it is. And this is the stipes are like the wings of the apartment building, the theca is like the room, and the zooid is like the person living in that room. So yeah, that's basically what the zooids are, the little individual creatures, and the theca is the cup that holds them. These things are great. They're great zone fossils because they evolve very, very rapidly into different species. They cover the entire ocean, and you could basically figure out what species they belong to by, how big they were, how many zooids, the angularity, how many stipes it had. It was awesome. I'm going to turn this to day because I can. And I'm going to go through the Ordovician. Oh, land spores. Yes, 470 million years ago is when land started first being colonised by, like, ferns and stuff. So that's when we start getting things appearing. Right. Still, the ocean is pretty much the main part of this, but we start getting these things called brachiopods and bivalves in the ocean. These are still with us today, like mussels, if you know. Mussels are bivalves, but you also get brachiopods. There is a difference. They're basically two shells with like a muscly tongue inside, represented by the grey. There is a difference. I'm not going into the difference. It's basically the way the shells are shaped. Fish, and when we're talking about fish, we're not talking about vertebrate fish. We're talking about fish that sort of have a spine, that's sort of cartilagey, not skeletal. But yeah, about then, probably earlier, but that's when we start getting evidence for it. Still many trilobites. Still, we get over that era. We do. And we end the Ordovician and the extreme cold. And we have and go into the Silurian, and we have an extinction event. The Ordovician Silurian extinction, 60% of all marine species died out, just gone, like in an instant. And we entered a greenhouse period, so it's possible that what was going on underground, under the sea, and starting to happen on land, messed up the atmosphere or the climate, and we started getting awesomeness. Bony fish with bones. So instead of having cartilage, they had skeletons. Yay! Oh, that's land spores. That was my attempt at land spores. Mycelium is not growing that quickly. We started getting vascular plants. Vascular plants are basically plants that have an internal transport system that can move their food around. That's what we started getting there. And then we end the Silurian, and we go into the Devonian. No, Devonian is actually named after Devon. And most of these names are British, because we sort of, at the time when things were being named and figured out, we sort of led the way. So we're pretty good at what's going on. Plants spread on the land. Yay! So we got lots of ferns. Didn't really have trees, although I have put one in there, but I couldn't get the ferns without the trees. Most of them were ferny plants, not anything like barky plants. But later on, in the Devonian, we get trees. We get lots of trees. In fact, trees sort of exploded around that point. Later on in Devonian, we started getting seed-bearing plants, so we started getting flowers. For some reason, there is an animal having a fight outside my house. Okay. We started getting ammonites. Now, ammonites are those swirly ones that you see, and they're basically, I say basically, they're sort of divided up into 3 subcategories. The earliest one is the goniatites, and they have these things called suture lines. As you can see, the swirly pink shell is the shell, and the lines are straight. The more wavy they get, the earlier they get, the later on they are. So goniatites have the straight ones, ceratites have the curly ones, and I can't remember the last one. But there's another one that has curly whirly ones, which is later on. So because we got lots and lots of trees, and we get organic life, which is crap tons of coal. Lots and lots of coal being laid down, and it's because actually plants make coal. Okay, it's in like animals make oil, plants make coal. So we had lots and lots of coal. This is why it's called the Carboniferous, because coal is made of carbon. And we started getting amphibians, so we get the first land. Oh God, that is a terrible frog, isn't it? Evil frog is evil. All hail the Hypnotoad. Anyway, amphibians. Yeah. So that's the actual first animal that could live on land and survive. And then later on in the is it the Carboniferous we're in? Yeah, we're in the Carboniferous. We start to get reptiles. So we go from marine, and then we go from sea and land to fully land-based animals. And then we get Pangaea. Pangaea is the supercontinent you've mostly heard of, where everything goes together and then splits apart later. So Pangaea is pretty much there. And then we go from the Carboniferous to the Permian. The Permian is black for a reason. We started getting ceratites, so we've gone from the goniatite ammonites to the ceratite ammonites, which are the wiggly ones, but not the super duper wiggly ones. And the reptiles become dominant on the land, so imagine all these cows, imagine that they're reptiles, imagine all the pigs, imagine they're reptiles. And then disaster strikes. We go from the Permian into the Triassic, and we get the Permo-Trias extinction event, which 96, as you can see, 96% of all marine life died, 70% of all terrestrial, I say life died, it's 96% of species died and 70% of species, okay? Not all life, just the species. And once we hit the Triassic, 251 million years ago, we hit the Mesozoic era. Mesozoic era, awesome. Pangea breaks up, and we get pterosaurs. So we've gone from sea to land to sky. Hello, buddy. How are you? Whoa, whoa. Yeah, so he flies. He flies. Badly. He flies like badly. I wonder. Do you want fish? Okay, so we get flying dinosaurs. And then we get the first mammals. And sorry guys, I am going to turn this off. Daytime, turn the rain off. Look at him, isn't he precious? And we get the first mammals. Now the mammals we're talking about little voles, mice, dormice, like tiny things that can hide from the big giant predators. And we're in the Triassic, 200 million years, and we go into the Jurassic, and one of my dinosaurs is missing. Two of my dinosaurs are missing. I had in there a stegosaur. Oh, he's over there. The Diplodocus is over there. We'll go see him in a minute. I also had a stegosaur, which might have been trampled by the Diplodocus, but he appears to have broken my fences. That's bad. Okay. Anyway, Stegosauruses and Diplodocuses, so we're getting lots and lots of like animal lights, and we also get the Archaeopteryx at this time. Now the Archaeopteryx, if you know, is basically a pterosaur, like that one over there, with feathers. So it's sort of the link between reptiles and birds. So it can fly, and it has feathers, and actually maybe they're not. Well, raptors also had feathers, anyway. So that's the missing link at that point. And we move onwards. Beep. And we get teeny tiny mammals. And we get plesiosaurs. Where's my plesiosaur? I had a plesiosaur. I am most upset because I had a plesiosaur. Did you eat him? No, you probably trampled on him. Okay, it looks like the dinosaurs are becoming disastrous. That's bad. But, you know, nothing I can do. Okay, we go from the Jurassic to the Cretaceous. Let's go have a look at my... Well, I say Diplodocus, but it's actually a Brachiosaur, but Diplodocus. Okay. Oh, I did not know you could do this. Wow. Okay, sorry. Oh, he cannot jump, but he can, like, trample land. Okay, that's mildly awesome. Oh, that's probably what happened to my plesiosaur and my triceratops. You trampled on them. Bad dinosaur. Bad. Okay, so, anyway. Sorry. Now I have my raptors, which appear to have gotten out. They came along in the Triassic. Actually, they came towards the end of the Triassic, and my Triceratops has been probably eaten by the Tyrannosaurus. The Tyrannosaurus, the Triceratops, and the Velociraptors all came at the end of the Cretaceous. You're a bad dino. You're a bad dinosaur. Bad dino is bad. Oh! Okay. Bad dinosaur. Anyway. Last laughs on you because, you know, giant meteor comes down and starts the KT boundary. Now, the Cretaceous is actually shown by a K because the Carboniferous actually had the C. So we call it the KT boundary, which is the Cretaceous Tertiary boundary. And by dinosaurs, and we start in the Cenozoic area. And we start in the Paleogene, 65 million years ago. And mammals and birds go whee, and they fly, and they become dominant species. Yeah, dinos, becoming the dominant species. Nah. That's pretty much all that happens. Like lots of different. I say all that happens. Lots and lots of different like species go poo 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 and awesome. Paleogene, Neogene, and we get the first hominids, and the hominids are a common ancestor to humans. I say common ancestor because we share a common ancestor with orangutans. We have not evolved from orangutans, even though they are like our closest like ape-like thing. We did not evolve from monkeys. We share an ancestor. The paths branched. One went to monkeys, one went to hominids. So that's how it works. And that sort of came in the middle of the Neogene. And Australopithecus. Australopithecus is thought to be one of our distant cousins, one of our common ancestors, etc. And then we go into the Quaternary. Quaternary is now. And if you look, the Quaternary started 2.5 million years ago. Consider that to 4.5 billion years ago. A lot of time has passed, and you know we are like small. Right, the first ones that really became noticeable as hominids were Homo habilis, and they lasted 1 million years. And then Homo ergaster and Homo erectus are thought to be sort of like the same sort of species, and they sort of intermingled, and yeah, it might be that they had a common ancestor and they split off into two different areas. That's possible, but you know they didn't last that long. Heidelberg man lasted 500,000 years. Right, now you know of two. I'm sure you know, actually, of two different species of humans. You know about Neanderthals, and you know about humans. Now, their official name is Homo sapiens neanderthalis, and ours is Homo sapiens sapiens. Okay, we are actually of the same sort of branch, but we've veered off. We shared the common ancestor. Now, 660,000 years ago, that common ancestor was around. And Homo sapiens neanderthalis, so Neanderthal man, evolved 260,000 years after that. Okay, and they died out 30,000 years ago. Rhodesian man was sort of a link. Homo sapiens, so we came around 200,000 years ago. That's how long we've been alive as a species. Not long at all. Like seriously not long. And we were in Africa at that time, and we moved out into Eurasia 125,000 years ago-ish. And, Homo florensis was like midget human. Yeah, like tiny humans. They're about 1 metre tall, 3 feet if you're American, but 1 metre to like the rest of the world ever. And they died out 12,000 years ago. So they were around for a while, but they weren't quite as successful as us. Hang on, it's Homo floresiensis. And Australia, we came to 40,000 years ago. And the Americas 15,000 years ago. We've only been in America as human beings for 15,000 years. Right. 200,000 years ago we evolved. 10,000 years ago we started to do agriculture with like plants and animals and all that sort of stuff. We went into Hawaii, New Zealand, Madagascar around those times. And now, from that point, we are now 7 billion people on this earth. Now, we have been alive for a very short time. If you look over there, we started about here on that geological timescale. I think there was a documentary I watched, and if for the history of time, we arrived, if it was in a day, the history of the Earth, we arrived at 2 minutes to midnight. We haven't been around for very long at all, and I guess we've got all that time in the future, hopefully, to see where it goes. And I mean, the Earth is going to end one day, and I just wonder where we're going to be on that timescale. Are we going to be here in this red part and then extinct, which is possible, or are we going to keep going and live as long as all the dinosaurs? It's possible. Let's go have a look at the dinosaurs. Evil T-Rex, raw. It seems to be chasing the... Oh, it's having a fight with a fairy. That's how the dinosaurs ended. They had a fight with a fairy. Makes sense to me. So, I shall, from the back of my brachiosaur, or diplodocus, or whatever it is, I shall wish you lot good day. Bye.